are the workhorse of the power generation industry.
category, but I guess this is part of the automotive systems. There is the AC, obviously, heater and AC, but heater is pretty simple. We don't need to talk about it. I mean, they basically route the radiator of water into the heater core, right? First, it goes through the evaporator from the AC, and then it goes through the heater. Any guesses why? Why would you not have a separate route for the heating only? I guess you wouldn't know if you never lived in a winter climate. Do you have winter? Okay. Well, see the route of the vent, of the ventilation. So you have the evaporator of the AC, and then the heater core. So this is the blower, the AC blower. So it blows air. Well, there is a filter, right? Filter, cabin air filter, right? Blower, and then the evaporator, the heater core, and then out the vent. Okay? Now, well, of course, there is the recirculation where you want it in your legs or windshield and all that. But think of it just vent, right? But it goes through the evaporator coils first before it goes through the heating coil. I mean, why not separate them, and depending, you know, whether you want to mix or not, you separate them. You mix the two air. But the reason is condensation. Okay? So if you ever lived in a winter climate, when I was in the States, one of the most annoying things about winter is that your windshield, what is that? Condensation, foggy, right? Condensation on the windshield. And I tried running my heater without the AC compressor on, and it just fogs all the way. Because as you heat things up, you know, so we won't talk about the thermodynamics here, but basically there's condensation. You need to dry up the air before you heat it up. So the function, during heating, the function of the evaporator is not to cool it down, but to condense the water, right? You want the water vapor to condense into water, and it, of course, it drips, right? Trying to draw water droplets, right? It drips onto your floor. So the water condensation here takes out the water vapor, so when you heat it up, you do not fog the windshield. You also notice that if you click maximum heat, if you do have a shortcut on your HVAC system, climate control, if you click maximum heat or the windshield direction, it will automatically turn on your AC compressor, and it will take air from the outside. Of course, there is the flaps, right? There is the recirculation, and there is the outside air. So you can switch between the two. So if you are doing heating on winter condition, it will automatically switch to outside, because the inside has all this water vapor accumulate, and then you'll turn on the compressor, and then you'll direct the vent to the windshield. So that's all done automatically, because it's assumed you do want the compressor on. So I don't know whether you know, but these things, the function of air conditioning is not just to cool things down. It's also to dry things up. Okay, so we feel comfortable in air-conditioned room, in hot climate obviously. We feel comfortable not just because of the temperature, but also because of the dryness, the humidity. We are comfortable around 40 to 50% humidity, 40 to 50. Not too dry, like in winter it can be like 10%. I mean, your skin will crack all over the place, but also not 70. So, you know, 40, 50, 60 maybe is a good, comfortable place to be. And in hot climates, we are at like 80, 90%, right? So the AC can cool it, can dry it up to like 60. So the water condensation on your AC, in your house AC also, right? You have the water dripping out. The purpose is condensation. So the evaporator coil will do that on top of cooling down your air. Okay, so that's just a short overview of how things are arranged in the AC systems in your car. But let's look at the AC in particular, because the heating, the water, the heating element, you run it from the radiator, not the radiator, but the engine cooling system. The engine cooling systems, before it goes through the radiator, while the thermostat is still closed, you first run it through the heater core, so you can get immediate heating. Okay. I think they have a good video on, I just want to show you the diagram.
Engine cooling system. The combustion of the fuel-air mixture results in the release of a huge amount of heat. The engine will quickly overheat. Review the liquid cooling system in detail.
Okay, so I just want to show you this. So you have the cooling jacket. So this is the route of the engine cooling systems, right? If you think about heating, then this is the source of the heating. There's a thermostat to determine whether you go to the radiator yet or not yet, right? During warm-up, but you just circulate within the engine. But if your heating is on, then it also circulates through the heating core, okay, the heater core. So that you immediately get the heat even though the thermostat has not opened yet, obviously, because the function of the thermostat opening is actually to cool down the engine, while right now we want to warm up the engine. So during warm-up, the coolant already goes through the heater core, so you get immediate heating there. Okay, so that's all I want to show about that. But let's talk about AC now.
Vehicles utilize air conditioners and heaters to cool and heat the interior in order to maintain a comfortable climate inside a car. Behind the dashboard, air ducts and the heater housing are located. The housing contains a heater core and a radiator that provides cold air.
Okay, so it goes through the evaporator first before it goes through the heater core.
Known as the air conditioning evaporator. The heater core heats the air that enters the passenger compartment. The air conditioning evaporator cools down and dehumidifies the inlet air. Additionally, the air is partially cleaned of small particles. Unlike the heater core, which is standard on all cars, the air conditioner is an optional equipment.
It's not optional.
That may be
Absolutely
used
not
on
optional.
The air conditioning system operates separately from the heater. To function, it requires an air conditioner compressor that is powered by the engine through a serpentine belt. Sometimes, a separate air conditioner belt may be used.
Okay, so it's mechanically driven, but it's not driven all the time. There is the magnetic pulley, the pulley magnetic clutch to turn it on or off. And that's what you turn on or off when there's the AC button on your climate control. That's what you do. Manually, you can.
Let's review the design and operation of a basic car air conditioning system. Its major components include the air conditioning compressor, the condenser, the receiver dryer, the evaporator, the expansion valve, 1 or 2 pressure sensors, 2 service valves, and the connecting tubing. And one.
Okay, so this is kind of the big picture. Okay, you have the condenser on the outside, the evaporator on the inside. This is exactly the same as your split air conditioner at home. You have the indoor unit, and then you have the outdoor unit, right? Way back in the 1980s, you have the window air conditioner you put on the window. So the evaporator coil is on this side, and the condenser coil is on the outside, but you punch a hole through the window. No longer the case now. You have indoor and you have outdoor at the remote place, and you have the freon or the refrigerant tube going through.
The main roles is assigned to the substance used in the system, the refrigerant. The key property of refrigerants is a low boiling point, for example, around -15 degrees Fahrenheit. These illustrations show that refrigerant boils even at 5 degrees Fahrenheit.
He's going to go through some thermodynamics. Have you taken thermodynamics? Yes, okay. Try to refresh your memory a bit. I also hate it, but I think it's also good science to understand, because that's exactly why these things can work. Okay.
The better the heat is supplied, the faster the process occurs, as heat is required for boiling. But let's include pressure as an additional factor. This graph shows the relationship between refrigerant state, temperature, and pressure. It is clear under which conditions the refrigerant is liquid or gaseous.
Any of you has a pressure cooker at home cooking? No? You know what it does? A pressure cooker? Why it can make your meat tender? It goes under pressure, obviously. So what does it do when you boil a meat in a pressure cooker? Water boils at 100. Under pressure, water does not boil at 100. Water boils at 110, 120. Okay, depending on the pressure, obviously. So you actually raise that line is the boiling point. And so as the pressure increases, the boiling point increases. So inside the pressure cooker, we cannot see it obviously, but inside the pressure cooker, the water is not boiling, but it's at 120 degrees Celsius. What it does is it can really tenderize your meat in a cooking situation. This is a different application, but in our case, under atmospheric condition, the boiling point is actually lower than the room temperature. So the refrigerant in room temperature is in a gas state, because the boiling point is -15 degrees Celsius. That's the boiling point in room temperature. So it will actually become a gas state if you just release the refrigerant in outside air. But again, in this refrigeration system, we are talking about everything is always under pressure. So we are not talking about that gas state always, but we are talking about the
Pressure,
state.
and will eventually become completely gaseous. Placing samples in pressure chambers such as 150 psi increases the boiling point of the refrigerant. Boiling continues only in the third scenario, despite no temperature changes. These physical properties are used in the air conditioner's operation cycle.
So he's going to go through the cycle. Basically, we begin here. We begin at the compressor, which is pumping it from low pressure to high pressure gas. Low pressure to high pressure gas. And this is where it condenses into liquid. And then here is a liquid high pressure. And then goes through the expansion valve, it becomes gas. And then gas gets pumped again. Okay, so there is a gas liquid change in state as it goes through this cycle.
The refrigerant transitions from gas to liquid and back to gas, effectively absorbing heat from the environment. Let us note that refrigerants are often referred to as freon, which is not always accurate.
Okay, I got caught there, right? I mentioned freon at one point. We'll old school. So in the old days, I think it was R12, the refrigerant code R12 is called Freon. Nowadays we use what in cars? R134A. Last time I remember. At home, split air conditioner for the home uses R32 is the latest, but previously it's R401 or 403. It has different boiling point, different heat capacity or cooling capacity, different pressure. It has its plus minuses, but the main concern with Freon, which was R12, was ozone. Pollution. If it gets released, it damages our ozone layer, so people get rid of it. Now it's more environmental friendly.
Freons are only a subset of refrigerants with a specific chemical composition, or those released under the registered trademark Freon. Let's go over the complete cycle of operation, taking note of the refrigerant state in the system and using average figures. The cycle begins with a compressor. The compressor doesn't run continuously. Rather, it turns on when the air conditioner is turned on. In the frequently encountered setup, engagement and disengagement are achieved through a pulley with an electromagnetic clutch. When the engine is operating, the clutch pulley revolves continuously.
It does become a wear and tear component, the pulley, the magnetic clutch, because the friction can, is abrasive eventually, and if it does not have enough friction anymore, it slips. When it starts to slip, if you notice your aircon sometimes it's working fine and then it's kind of underperforming, but then randomly at one point it just becomes normal again. If you see that kind of unpredictable behavior, that's one of the culprits, because it's just a stick and slip phenomenon. You might need to replace the magnetic clutch.
The clutch pressure plate, however, begins to rotate with the compressor only once the electromagnetic clutch is engaged. Let's turn on the air conditioner. The electric current flows into the coil stator, located behind the pulley. The generated magnetic field attracts the pressure plate to the pulley, connecting them.
Pulls it in.
The compressor starts. The compressor forces the refrigerant to circulate in the system and also compresses the gaseous refrigerant, raising the pressure from 45 to 220 psi.
By the way, this is a piston type, which is the most common type. I don't know which cars has which type. In all my experience, it has been just a piston type. Do you know what cars has the scroll type? I mean, this is the most common. Even I think the German cars still uses piston types too. It's just that they have a variable adjustments on the swash plate. This is called the swash plate. So it has a pivot, like animated.
As a result of the compression, its temperature increases to 175 degrees Fahrenheit. The graph indicates that the refrigerant is gaseous under these conditions.
Yeah. Well,
Easier for us to turn the refrigerant into a liquid
That's
by
the
releasing heat
compressor.
into the surrounding air.
you'll see it has a symbol on
Find
that.
more 3D video
That's
lessons in
thermodynamic
our
chart.
Car Anatomy online course. Next, the gaseous refrigerant is then sent to the condenser, located in the front of the vehicle, in front of the cooling system's radiator.
So it's condenser first, then radiator. Make a guess why. Why do you put the condenser in front of the radiator? Which one is hotter? You think?
The radiator is hotter.
Yeah, because the radiator is hotter than you. Because in front of the car, you're trying to cool these down, right? So first you cool the condenser first, and then the radiator. Because if you put the condenser behind the radiator, it's going to be heated up instead of cooled down. Condenser is at around 70 degrees Celsius. Radiator, we're talking 100
condenser is a type of radiator with multiple tubes and cooling fins, but its purpose is to condense the refrigerant. You can see one potential layout for the condenser's interior, in which the flow is split into multiple tubes going in the same direction, and each tube is further divided into multiple flows.
Basically a heat exchanger.
This maximizes the heat transmission area. To improve visibility, let us simplify the design to a single serpentine tube. The condenser cools the refrigerant to 120 degrees Fahrenheit, causing it to condense, that is, transit from gas to liquid.
So the compressor gets it up to 15 bar from like 3 bars. Then it's cooled down here. So before the refrigerant go into your car, it's first being cooled down. The compressor also generates heat. It puts heat into the gas also. So we are cooling down from like 80 degrees Celsius to 50. Of course, you cannot go below the ambient temperature, right? Because obviously. So we went from a low pressure, low temperature, relatively low temperature, to high temperature, high pressure. This is the compressor, right? So you guessed it. What's going to happen with the condenser? Just looking at these numbers. Where are we on the chart? We're cooling it down. We don't want to lose too much pressure, right? So we're going down here. So we are entering a liquid phase, lower temperature, but same high pressure. Okay, that's the second cycle.
The graph makes this quite evident. The temperature falls into the liquid state zone. At this point, the refrigerant cools, releasing the heat absorbed from the air entering the automobile, but we'll get into that later.
Can you guess what the chart is going to look like? The refrigeration cycle? Anybody remember from thermodynamics? No? Where are we on the third step? Where are we going?
Bottom right.
Okay, we're going to go to bottom left and then up again back. So we make that diamond shape. It's hard to make sense.
Additionally,
But,
when the air conditioner...
but by the way, your engine does the same thing. The Carnot cycle is also a thermodynamic cycle. You also have this box. The bigger the box, the more horsepower you make. Here, the bigger the box, then the bigger in the chart, the bigger cooling capacity.
On, the cooling system's fans turn on as well, enhancing refrigerant cooling. The next device in the path of the liquid refrigerant is the receiver dryer. In modern systems, a device resembling the receiver dryer is installed in the condenser and may be referred to as a modulator. This device collects and holds the refrigerant in liquid form, allowing for a smoother and more homogeneous outflow. Another task is to dehydrate the refrigerant. This is done by an absorbent material that absorbs moisture that has entered the system.
Ideally, there is no moisture entered the system, right? This is a closed system, but you never know. I mean, things can get in, small leaks. This is also, you want your refrigerant to be dry, very dry. That's why if you notice people installing your split air conditioner at home, they first vacuum the entire pipe. So they use a vacuum pump it up, out for like 15 minutes, and then they get the refrigerant in. So you don't want any moisture in the system, corrosion and all that.
Additionally, the refrigerant is cleaned of dirt and wear debris.
Where do you think the debris can come from?
Usually the piping is plastic, so maybe
Piping is not plastic. Piping is
no, like the connection one, like the black one. Usually part of it is not plastic, rubber, so maybe it can break down. down.
Yeah, some rubber seals can break down. The other thing is your piston, right? Your piston, yes, it can have metal shavings, tiny dust, but yeah, just acts as a filter.
Various types of filters are used for this purpose. The next component in the system is a service valve. Actually, there are two service valves. One
This
on
just
the
to
pressure
check and
side
to do
and
maintenance.
another on the low pressure side.
Usually you just use the
We'll
low
return to
pressure
them
side.
later. Next comes a pressure sensor, protecting the system from both overpressure and underpressure. The refrigerant then enters another device, known as the expansion valve. It is located in the passenger compartment, or on the partition between the passenger and engine compartments, adjacent to the evaporator. Let's take a closer look. Inside, there is a valve through which the liquid refrigerant is sprayed into the adjacent chamber. Due to the small cross-sectional area, there is a pressure drop from 220 to 45 psi. At this pressure, the refrigerant boils and changes from liquid to gaseous state.
Okay, so this is a tiny piece, but this is actually one of the most critical component of your refrigeration cycle. In the chart, we are going from a high pressure, high temperature, relative high temperature, to sustain, lower the pressure, but then you cool it down significantly. But the cooling, the most significant cooling does not come from the liquid being cooled, but actually by the transition of liquid into gas. Have you ever been in like a zoo or some outdoor theme park and then they put a fan with spray water, the mist? Why do you feel colder? I mean, the water is not cold. The water in the tank, I mean, it's the outdoor temperature, like 30 degrees Celsius. But why is it when it's sprayed into mist, you feel cold?
Psychology.
It's not psychology, it's actually science. It's the changing from liquid to gas actually takes away a significant amount of heat, especially water. So, if this is the energy you have to put in to boil water, first you take it from here to 100 degrees Celsius, right? From like 20 degrees Celsius water into 100 degrees Celsius. And then, believe it or not, to take it from 100 degrees Celsius water into 100 degrees Celsius vapor, you actually have to put in some energy. Okay, so boiling does not stop at 100 degree water. If you notice your water boils further into vapor, there is actually another amount of energy. And this transition is the amount of energy that you feel taken away as your body is cooled down by the mist. You see? So when they spray water, I mean, just use a typical bottle spray, right? What they use in cutting your hair, right? When they spray, you feel cold. And the cold is actually because the liquid transition into gas, even though it's at the same temperature. But it transitions to gas and you feel the cold because your skin got the heat taken away. And guess what? That's how you sweat. Why do you sweat? Why our body is designed to sweat? It's to take away heat. So when you sweat, you basically have a layer of some thin liquid, your sweat, and then air comes through and you feel cold. And this is also why you feel cold even without the mist. If you are in an outdoor situation, you have this little handheld fan, right? And you blow air around your body. Why do you feel cold? The air you blow is the same outside air. Why do you feel cold when you have a fan to your face? It's your sweat. So basically, you have sweat on your skin even though you don't feel really sweating, but just a thin layer of sweat. When you blow air, the air actually evaporates your sweat. And during that evaporation, the heat is taken away, and that's essentially cooling. Okay? So that's going to happen here in a much more significant way than your sweat. When it changes state from liquid into vapor, that's when the majority of the heat transfer comes in.
The refrigerant temperature rapidly lowers to its boiling point at this pressure. The process of refrigerant boiling occurs during its passage through the evaporator. Let's streamline the refrigerant path once more for better visibility.
That's why it's called the expansion valve, and then this coil is called the evaporator because it evaporates the refrigerant. Now you know. So, as it evaporates here, it becomes really cold. Really cold. And that's all these metal fins becomes really cold. You blow air through it, and that's how you cool down the air. And the water or vapor also condenses at the evaporator.
Boiling, or the rapid shift from a liquid to a gaseous state, is accompanied by the absorption of heat from the environment, as the conversion of liquid to gas requires heat. In this situation, heat absorption occurs from the evaporator and the surrounding air. So all we have to do now is direct the airflow through the evaporator into the vehicle's interior to reduce the air temperature. The heater fan generates airflow, and the air ducts direct it in the desired directions. When the refrigerant passes through the evaporator, it entirely changes to a gas.
So that's the final state. From this point to this point, okay, you increase the temperature, pressure is about the same, and then it enters the compressor again, and the whole cycle kind of.
At the outlet, the gas passes through the same expansion valve, which helps maintain a consistent temperature in the evaporator by regulating the flow of refrigerant.
Now, this is the regulation of the spraying of the liquid. Now, we underestimate the need for this. In the old days, it's just a tiny hole. If you put high pressure liquid into a tiny hole, you get a mist, right? But this mist got to be controlled. And in the modern thermal expansion valve, there is some regulation of the amount of mist.
Valve is adjusted by three forces: the adjustment springs pressure, gas pressure in the evaporator, and gas pressure in an independent chamber separated by a diaphragm. The spring pressure is factory adjusted, and the gas pressure behind the diaphragm plays a key role. If the temperature of the outgoing refrigerant rises, so will the temperature of the gas in the detached chamber, causing thermal expansion, and as a result, pressure in the valve via the diaphragm. The valve will open somewhat more, resulting in more refrigerant being injected.
In other words, when your evaporator is doing a lot of work, meaning that the exiting gas is at a higher temperature, then you need more refrigerant, right? So this is almost like a thermostat. Think about it. The gas exiting the evaporator will result in increase of refrigerant supply, meaning that we need more cooling.
Which lowers the temperature of the refrigerant in the evaporator and the temperature of the outflow. A cooler stream cools the gas behind the diaphragm, causing thermal compression and subsequent valve closure. As a result, the refrigerant injection rate reduces while the outflow temperature rises again.
The opposite.
The valve, therefore, is constantly balancing to maintain a specific temperature at the evaporator output, which is determined during the expansion valve's production.
I think it's a great mechanical device. I mean, no electronics here, but it's self-regulating.
The low temperature, low pressure gaseous refrigerant enters the compressor again, and the cycle is then repeated. The AC system has two sides, high pressure and low pressure. Low pressure tubes are larger in diameter than high pressure tubes. Each side features a service valve for air conditioner maintenance.
The high pressure service valve is not often used. I mean, it's used to see whether your compressor is doing its job. So you compare the low pressure and the high pressure. You also try to detect like clogging on the receiver dryer. But your refrigerant enters on the low pressure side. So if you want to add refrigerant, you add it on the low. Because that's the suck. That's where it's sucked in. The compressor suck in the refrigerant. Right?
One service valve is located on the high side and the other on the low side. Valve caps have markings that show which side the valve is located on. Let's note that for the long-term operation of compressors, lubrication of the moving parts is necessary. Thus, the system employs a special compressor oil, which flows throughout the system alongside the refrigerant.
So your refrigerant is actually mixed in with oil, and that's why if we have leakage, you'll see dirt on the pipe or on the flaring joints. That's because if your refrigerant leaks out, then there is some oil that leaks out also, and dirt usually collected. So there is lubrication, and that is critical, by the way.
Settling on and lubricating primarily compressor parts. We have examined a typical design of a modern automotive air conditioner.
Oh, it's going to talk about some.
Let's take another look at the entire cycle, this time with a diagram. The compressor compresses the gas, raising both temperature and pressure. The condenser releases heat and converts the refrigerant into liquid. The receiver dryer filters and stores liquid refrigerant. The expansion valve generates a pressure differential due to its narrow opening area and regulates refrigerant supply to the evaporator.
It's going to talk about different thermal expansion
As it
valves.
travels through the evaporator, the air conditioner will cut off temperature sensor.
Okay, let's talk about the sensing because it has some controls here.
The refrigerant temperature sensor data, together with other sensor readings, can aid in diagnosing a slow leak of refrigerant from the system. The evaporator temperature sensor keeps the evaporator from icing while the air conditioner is running.
So the coil can sometimes be very cold, maybe too cold, and you start to build ice on it. In fact, your freezer has the cycle of actually melting the ice inside those coils. I mean, this is the same thing that works in your split AC air conditioner and also your refrigerator and your freezer. It's just different temperature or operating temperature. But the evaporator temperature sensor is one that senses if it's too cold and it has to let go of the cycle a little bit.
This requires some explanation. If the air temperature drops below freezing as it travels through the evaporator, the air conditioner will cut off to avoid the condensed moisture from icing on the evaporator.
If it ice and it blocks the airflow and it kind of built up on itself.
Condensation on the evaporator's surface and probable drainage under the automobile is a normal occurrence. In cold weather, at temperatures around the freezing point or lower, the activation of the air conditioner may be prevented, for example, based on the readings of the external temperature sensor, the evaporator temperature sensor, or another temperature sensor. This is important because in cold conditions, the refrigerant may not receive enough heat during the boiling stage to transition from liquid to gas. As a result, the boiling ceases and liquid refrigerant can enter and harm the compressor.
Your compressor is a gas compressor. It's not designed to handle liquid, so it's going to damage itself if liquid gets in.
Next, let's note that compressors come in various types based on their internal design. We'll list the three main types: the already familiar piston compressors, scroll compressors, and rotary vane compressors.
Your residential air conditioner usually uses scroll compressors. It's much more quiet,
All the
more expensive.
designs are common and can have subtypes. Compressor pulleys are mostly equipped with an electromagnetic clutch, but there are also designs without an electromagnetic clutch, where the compressor runs continuously.
Notice how it adjusts the amount of compressing action using that lever arm.
In this situation, the air conditioner is shut off by adjusting the compressor capacity.
See the displacement
When the
change?
air conditioner is turned off, the compressor continues to operate with a low, near zero load on the engine. For example, the air conditioner is now turned off. The compressor is still running, but the piston stroke is very low, and the compressor draws minimal power from the engine. When we switch on the air conditioner, the piston stroke is increased and adjusted to the desired performance.
So this is a more elegant way to adjust it instead of turning on and off the clutch, right? Obviously, it exists in more expensive cars. In many German cars, you don't hear the clicking of the AC compressor because it's variably adjusted. So the compressor is always spinning, it's always engaged, but then you have this lever that pushes out and then angles the swash plate, and so as it's angled, then you do this pumping. But if it's retracted, then it's not pumping.
Note that
I think that's enough.
ignore refrigerant dosing.
Yep, that's good enough for the AC. Now that's a pretty in-depth one we did. I think it's the evolution of refrigeration technology has gone that far. But man, I think it's the most awesome invention of human. AC. I love AC. Cannot stand the heat. Is it hotter in Maltese?
About the same.
It's about the same.
About the same.
About the
A
same
little bit
weather.
colder. A little bit colder in the morning. especially.
How far are you from the equator?
You're
South, right?
South, yeah. And in the middle, I guess. We're at the same.
Oh, you are near the equator?
Yeah, we're tropical, so in the middle of
I
the
see.
winter. We're tropical region. So we have both winter and summer, but it's not like winter. It's like the coldest we
I
get
see.
is 15 degrees.
15 degrees
Yeah,
Celsius.
15, like on mountainous maybe 10, maybe. Very rare.
That's nice. That's really nice.
In the morning it's cold, like yeah, around this temperature, but
So December is hot,
hot, very hot.
like Australia, right?
Yeah,
Because
very
we're on the
hot.
south side.
Very
I
hot.
see. So December, you're talking like Jakarta weather, 30,
No,
32.
Yeah, I guess. Only during noon, and then after that it cools down rapidly.
Okay.
Yeah,
So
it's maybe 10 to 2, 4 or something.
Okay. So during December is a little bit colder than Jakarta. I mean, just moderate, more
Yeah.
moderate.
Yeah.
But then in June,
It's
what's your daytime?
uh,
22 daytime during
Daytime?
the day. 25.
yeah, around 25.
Okay.
25.
And then at night it can be like 15.
No, 25 they're cold.
Yeah. Okay.
So
That
it's
seems
6 months,
nice.
6 month split of winter and summer.
That's a nice moderate climate
Yeah,
there.
it's actually pretty good.
Yeah.
But December is so hot. So hot.
And then I bet it's humid too because you're an island.
No. It's not that humid.
Oh,
Only
really?
coastal region. Only coastal region.
I see.
because we have the sea close by.
Do
But
you have mountainous area?
yeah, we do have mountainous area, but because it's windy, the humidity didn't stay. Only in December and February, because we have cyclones and stuff. So you get rain and then hot, rain and then hot. The humidity rises, but most of the time because it's like quite windy, so you can't feel it that much. But in here, you go out, you feel it like immediately. Your hand becomes sticky. But no, but there it's really okay. Not very rare.
Man, I probably should go there someday.
Yeah.
That's like a nice. So a lot of tourists come to Maltese.
Yeah, that's our main sector.
Oh, you are a destination.
Yeah.
Okay.
We are the best destination in Indian Ocean. The first one. And then we
Nice.
are among the top 10 most beautiful beaches in the world.
Wow.
Yeah, so we have, before us it's Maldives, and then Seychelles, and then you have like the Hawaii type thing.
Yeah,
but
yeah.
we're on the top of the list.
Okay.
We are a honeymoon destination. Yeah.
Okay. Cool. All right. Well, let's move on. We spent quite a bit of time there. The rest are actually simpler. Power windows. I mean, it's just a motor and mechanics. But let's go through it.
Are you amazed at how easily you can raise and lower your though even if you try that which enables the window to slide smoothly, is illustrated here. Now, obviously, some mechanism in the door has to push or pull the window.
That's the old days. Who experienced that? You did? Really? Okay.
Taxi.
Taxi.
The old
These
Vios Bluebird taxi.
It still uses manual crank?
Yeah.
Wow.
Operations can be accomplished by a simple crank and gear arrangement, like this. Observe how the different parts
He's explaining the evolution of the modern power window. So this is the old style.
of the mechanism move when you rotate the crank. The end motion will either push or pull the window. As you can see, the glass is supported at a single point at all times. Therefore, a small difference in friction could cause an imbalance, and the window may not move straight. If we support the support link of the glass at 2 points, it can solve this problem. This design suggestion can be easily understood from this weightlifter analogy. Therefore, we add 2 more linkages, as shown. 1.
Sometimes when you study the history of some design, I mean, you also learn some good design principles.
One end of these newly introduced linkages are pivoted in the middle, and the other ends are connected to the sliders. The mechanism we have just developed is known as a scissor-type mechanism. The 2 supports we gave to the glass makes the mechanism quite robust. Interestingly, the scissor mechanism is getting used in many weightlifting equipment, folding gates, and even in your computer keyboard. This cool mechanism was in the mainstream of car windows till the 1990s, and some classic cars still use them. The way it works is a pleasure to watch. The mechanism's top portion always moves perfectly straight. However, this arrangement has one main drawback. It will make the window fall abruptly at the bottom. To avoid this issue, let's place a spiral spring on the pivot point. This spring unwinds during the window's upward movement and compresses for its downward movement. Now the glass doesn't fall suddenly, and this new arrangement also reduces the effort needed for the upward movement of the glass. Another issue is that one can operate this mechanism even by pushing or pulling the glass.
So obviously you don't want somebody can slide it down, right?
This means that theft is quite easy if car windows are equipped with this design. This simple worm gear arrangement can solve this issue effectively. The worm can rotate the gear, but the gear can't rotate the worm.
This concept in a mechanism is called back drivable, right? Can you drive it back from the opposite side. We'll learn a little bit more about this in machine design. But a worm gear set is not back drivable, and that's what we want, right? You want one side to drive the other, but not the other to drive back.
This means only if we input motion to the worm, the mechanism will work. The crank is connected to the worm, so the passenger can easily operate the mechanism. However, when somebody tries to move the glass, the input motion goes to the worm gear and everything gets stuck. Nobody can move the window glass up or down forcibly. Moreover, the worm and gear arrangement also works as a torque multiplier. Simply by connecting a DC motor to the worm, we can convert the manual window to a power window. The major concern with this linkage mechanism is that it has many sliding contacts.
I think there are some power windows still using this mechanism. My Honda though uses the cable pulley.
Frictional losses will be high due to this. This design is improved by using a rope and pulley system. You can see two plastic sliders here. They are connected with the rope. These sliders support the glass. The way power and motion generated by the motor reach the rope is illustrated here.
In cheaper cars, the rail is only one. In my Honda Jazz, you only have one rail in the middle. This one has two rails. Is that typical? I don't fix power window that often. But usually the motor is the one that wears out the brushes.
For smooth operation, two vertical guides are used. This mechanism is smoother than the previously seen linkage mechanism since it has very few metal-to-metal contacts. Some of the rope and pulley mechanism's known issues are listed here. Thank you for watching the video.
Okay. Window regulator. So, in many cases, I mean, that's a scissor type, right? But in many cases, it's a single rail like this. And over time, this gets kind of dry if you don't loop it up. And the cable that goes through the sheath, because there is it's like a hose, right? The cable, it's like a bicycle cable. And so it needs some lubrication, it can get dry. The other point of maintenance is this motor. It's a simple DC motor, so it has carbon brush on the commutator. It can wear out. Yeah. If you want to go cheap, you replace the carbon.